Hi, welcome to our channel of IGNOU Audiobooks, Indira Gandhi National Open University, School of Management Studies, SEMS, Postgraduate Diploma in Operations Management, PGDIOM. Semester I, MMPO 001 Operations Research. Block-1 Introduction to Operations Research. Unit-1 Operations Research and Overview. After studying this unit, you should be able to understand the meaning, purpose, and limitations of operations research. Explain the historical background of operations research. Discuss the approach and tools of operations research. Understand the applications in real world and importance of computer packages. 1.1 Introduction. Operations research is a distinct discipline in its own way but also become an important tool in all areas of study. Operations research, OR, as a formal subject is about 70 years old and its origins may be traced to the latter half of World War II. It is an interdisciplinary approach that provided useful solutions to problems of military operations in World War II, and has since been found equally successful in non-military operations. Most of the OR techniques that are commonly used today were developed over, approximately, the first 20 years following its inception. However, for the last few decades, there has been a remarkable expansion in the breadth of problem areas to which OR has been applied, and in the magnitudes of the problems that can be addressed using OR methodologies. Today, operations research is a well-developed field with sophisticated array of techniques that are used routinely to solve problems in a wide range of application areas. The tools of operations research are not from any one discipline, rather mathematics, statistics, economics, engineering, psychology, etc. have contributed to this new body of knowledge for decision making. Today, it has become a professional discipline that deals with the application of scientific methods for decision making, and especially to the allocation of scarce resources. A common misconception of operations research is a collection of mathematical tools. Though it is true that it uses a variety of mathematical techniques, operations research has a much broader scope. It is in fact a systematic approach to solving problems, which uses one or more analytical tools in the process of analysis. Basically, OR may be viewed as a scientific approach to solving problems. It abstracts the essential elements of the problem into a model, which is then analyzed to yield an optimal solution for implementation. The mathematical details and the specific techniques used to build and analyze these models can be quite sophisticated and are addressed elsewhere in subsequent units of this book. The emphasis of this unit is on the approach. A brief review of the historical origins of OR is followed by a detailed description of its methodology. In this unit, several examples of successful applications to typical problems are given. Generally, an OR project comprises 3 steps: 1. Building a model, 2. Solving it, and 3. Implementing the results. The emphasis of this unit is on the first and third steps. The second step typically involves specific methodologies or techniques, which could be quite sophisticated and require significant mathematical development. Several important methods are provided in subsequent units. The student who has an interest in learning more about these topics is referred to one of the many excellent texts on OR that are available today and that are listed under further reading at the end of this unit, e.g., Hillier and Lieberman, 1995, Taha, 1997, or Savini et al., 2006. 1.2 History of OR. OR has its beginning in World War II. The term operations research was coined by McCloskey and Trifton in 1940 in UK. British scientists set up the first field installations of radars during the battle and observed air operations. Their analysis of these led to suggestions that greatly improved and increased the effectiveness of British fighters, and contributed for successful British defense. Operations research was then extended to anti-submarine warfare and to all phases of military, naval and air operations, both in Britain and the United States, and was incorporated in the post-war military establishments in both the countries. The effectiveness of operations research in military spreads interest in it to other governmental departments and industry. In the USA, the National Research Council formed a committee on operations research in 1951, and the first book on this subject, Methods of Operations Research, by Morse and Kimball, was published. In 1952, the Operations Research Society, America, came into being. Success of OR in military attracted the attention of industrial managers who were seeking solutions to their complex problems. Today, almost every large organization or corporation in affluent nations has staff applying operations research, and in government the use of operations research has spread from military to widely varied departments at all levels. This general acceptance to OR has come as managers have learned the advantage of the scientific approach on which OR is based. Availability of faster and flexible computing facilities and the number of qualified OR professionals enhance the acceptance and popularity of the subject. The growth of OR has not been limited to the USA and the UK. It has reached too many countries of the world. Indicative of this is that the International Federation of Operations Research Societies, founded in 1959, now comprises member societies from many countries of the world. India was one of the first few countries who started using OR. In 1949, first OR unit was established in Regional Research Laboratory at Hyderabad. At about the same time, another group was set up in Defense Science Laboratory to solve the problems of stores, purchase and planning. In 1953, OR unit was established in Indian Statistical Institute, Calcutta, with the aim of using OR methods in national planning and survey. OR Society of India was formed in 1955. This society is one of the first members of International Federation of Operations Research Societies. This society started publishing Upsearch, a learned journal on this subject, in 1963. Today OR is a popular subject in management institutes and schools of mathematics and is gaining currency in industrial establishments. George Dantzig, who in 1947 developed the simplex algorithm for linear programming, ALP, provided the single most important impetus for this growth. To this day, ALP remains one of the most widely used of all OR techniques, and despite the relatively recent development of interior point methods as an alternative approach, the simplex algorithm, with numerous computational refinements, continues to be widely used. The second major impetus for the growth of OR was the rapid development of digital computers over the last few decades. The simplex method was implemented on a computer for the first time in 1950, and by 1960 such implementations could solve problems with about 1,000 constraints. Today, implementations on powerful workstations can routinely solve problems with hundreds of thousands of variables and constraints. Moreover, the large volumes of data required for such problems can be stored and manipulated very efficiently. Once the simplex method had been invented and used, the development of other methods followed at a rapid pace. The next 20 years witnessed the development of most of the OR techniques that are in use today, including nonlinear, integer and dynamic programming, computer simulation, PUT, CPM, queuing theory, inventory models, game theory, and sequencing and scheduling algorithms. The scientists who developed these methods came from many fields, most notably mathematics, engineering, and economics. It is interesting that the theoretical basis for many of these techniques had been known for years, e.g., the Archive formulae used with many inventory models was developed in 1915 by Harris, and many of the queuing formulae were developed by Lang in 1917. However, the period from 1950 to 1970 was when these were formally unified into what is considered the standard toolkit for an operations research analyst and successfully applied to problems of industrial significance. The following section describes the approach taken by operations research in order to solve problems and explores how all of these methodologies fit into the OR framework. 1.3 Approach, Techniques and Tools. An OR team. In some companies, this may be single individual, consists of trained researchers utilizing the skills and tools of applicable sciences, without any preconceived ideas of what the correct solution should be. The first step is to formulate the problem, after which a mathematical model is generally constructed to represent the system being studied. Mathematical models or conceptual models may be in the form of equations or formulae developed to relate important factors or variables of the operations under study. The model then can be tested and operated upon mathematically to determine the effects of changing the values of the variables. Optimization of some criterion may be purpose of such an exercise. Optimization means achieving the best, maximum or minimum value of the criterion. Suboptimization occurs either when some criterion subordinate to the overall criterion is optimized or when the overall criterion is optimized over only a portion of the total of all possible alternative actions. A criterion is a measure by which results can be evaluated. It measures the differences of the operations under study in terms of the ultimate objective of the operations, and may be net profit, return on investment, cost, or some other thing appropriate to a particular study. Operations research uses any suitable techniques or tools available. These frequently include common mathematical or statistical procedures, cost analysis, or electronic computation. However, OR analysts have given special impetus to the development and use of techniques like linear program, waiting line theory, game theory, inventory control models, and simulation. In addition, some other common tools are nonlinear programming, integer programming, dynamic programming, sequencing theory, Markov process, network scheduling, PUT and CPM, symbolic logic information theory, and utility value theory. The list, of course, is not exhaustive. Detailed discussion on some of these techniques will be presented in appropriate units. But, here, it is meaningful to write a brief explanation of these techniques. 1. Linear programming. Linear programming is basically a constrained optimization technique which tries to optimize some criterion within some constraints. It consists of an objective function which is some measure of effectiveness like profit, loss, or return on investment, and several boundary conditions putting restriction on the use of measures. Objective function and boundary conditions are linear in nature. There are methods available to solve a linear programming problem. 2. Nonlinear programming. Nonlinear programming methods may be used when either the objective function or some of the constraints are not linear in nature. Nonlinearity may be introduced by such factors as discount on price of purchase of large quantities and graduated income tax, etc. Linear relationships may be employed to approximate nonlinear conditions, but the approximation becomes poorer as the range is extended. Nonlinear methods may be used to determine the approximator in which a solution lies, and linear methods may then be used to obtain a more exact solution. 3. Integer programming. Integer programming method may be used when one or more of the variables can take only integral values. Examples are the number of trucks in a fleet, the number of generators in a powerhouse, and so on. Approximate solutions can be obtained without using integer programming methods, but the approximation generally becomes poorer as the numbers become smaller. There are techniques to obtain solution of integer programming problems. 4. Dynamic programming. Dynamic programming is a method of analyzing multi-stage decision processes, in which each elementary decision is dependent upon those preceding it as well as upon external factors. It drastically reduces the computational efforts otherwise necessary to analyze results of all possible combination of elementary decisions. 5. Waiting line theory or queuing theory. Waiting line theory or queuing theory deals with the situation in which queues are formed. Customers waiting for service, machines waiting for repairmen, and aircrafts waiting for landing strips are some of the situations in which queue is formed. If we assume that there are costs associated with waiting in line, and if there are costs of adding more channels, service facilities, we want to minimize the sum of costs of waiting and the costs of providing service facilities. Waiting line theory helps to make calculations like expected number of people in the queue, expected waiting time in the queue, expected idle time for the server, etc. These calculations then can be used to determine the desirable number of service facilities. 6. Game theory. Game theory is used for decision making under conflicting situations where there are one or more opponents. Opponents, in game theory, are called players. The motives of the players are dichotomized. The success of one player tends to be at the cost of others, and hence they are in conflict. Game theory models a conflict situation and helps us to improve the decision process by formulating appropriate strategy. 9. An overview. Identifying critical activities and critical path. 2 basic techniques in network operations research scheduling are program evaluation and review technique, PERT, and critical path method, CPM. CPM is used when time taken by activities in the project are known for sure, and PERT is used when activities time is not known for sure. Only probabilistic estimate of time is available. 12 Symbolic logic. Symbolic logic deals with substituting symbols for words, classes of things, or functional systems. It incorporates rules, algebra of logic, and propositions. There have been only limited attempts to apply this technique to business problems. However, it has had extensive application in the design of computing machinery. 13 Information theory. Information theory is an analytical process transferred from the electrical communication field to operations research. It seeks to evaluate the effectiveness of information flow within a given system. Despite its application mainly to communications networks, it has had an indirect influence in simulating the examination of business organizational structures with a view to improving information or communication flow. 14 Utility value theory. Utility value theory deals with assigning numerical significance to the worth of alternative choices. To date, this has been only a concept, and is in the stage of elementary model information and experimentation. When developed, this may be very helpful in the decision-making process in assessing the worth of various possible outcomes. 1.4 Phases and processes of OR. Study. OR is logical and systematic approach to provide a rational basis for decision making. The phases and processes of OR study must also be quite logical and systematic. There are 6 important steps in our study, but it is not necessary that in all the studies each and every step is invariably present. These steps are arranged in the following logical order. Step 1. Observe the problem environment. Step I in the process of OR study is observing the problem environment. The activities that constitute this step are visits, conferences, observations, research, etc. With the help of such activities, the OR scientist gets sufficient information and support to proceed and is better prepared to formulate the problem. Step 2. Analyze and define the problem. Step 2 is analyzing and defining the problem. In this step, not only the problem is defined, but also uses, objectives and limitations of the study are stressed in the light of the problem. The end results of this step are clear grasp of need for a solution and understanding the nature. Step 3. Develop a model. Step 3 is to construct a model. A model is representation of some real or abstract situation. OR models are basically mathematical models representing systems, processes or environment in form of equations, relationships or formulae. The activities in this step defining interrelationships among variables, formulating equations, using known R models or searching suitable alternate models. The proposed model may be field tested and modified in order to work under stated environmental constraints. A model may also be modified if the management is not satisfied with the answer that it gives. Step 4. Select appropriate data input. Garbage in and garbage out is a famous saying. No model will work appropriately if data input is not appropriate. Hence, taking right kind of data is a vital step in our process. Important activities in this step are analyzing internal external data and facts, collecting opinions and using computer data banks. The purpose of this step is to have sufficient input to operate and test the model. Step B. Provide a solution and test reasonableness. Step B in our process is to get a solution with the help of model and data input. Such a solution is not implemented immediately. First, the solution is used to test the model and to find limitations if any. If the solution is not reasonable or if the model is not behaving properly, updating and modification of the model is considered at this stage. The end result of this step is solution that is desirable and supports current organizational objective. Step 6. Implement the solution. Implementation of the solutions obtained in previous step is the last step of our process. In OR, the decision making is scientific, but implementation of decision involves so many behavioral issues. Therefore, the implementing authority has to resolve the behavioral issues. He has to sell the idea of use of OR, not only to the workers but also to the superiors. Distance between management and OR. Scientists may offer a lot of resistance. The gap between one who provides a solution and one who wishes to use it should be eliminated. To achieve this OR, scientists as well as management should play a positive role. A properly implemented solution obtained through OR techniques results in improved working and wins the management support. A brief summary of steps, process activities and process output is presented below. Look at the screen. 1.5 Typical applications of OR. Although the complete list of OR techniques and their applications would fill volumes itself, the following is an abbreviated set of applications to show how widely these techniques are used today. 1. Accounting, cash flow planning, credit policy analysis, planning of delinquent account strategy. 2. Construction, allocation of resources to projects, determination of proper workforce, deployment of workforce, project scheduling, monitoring and control. 3. Facilities planning, factory size and location decision, hospital planning, international logistics systems design, estimation of number of facilities required, transportation loading and unloading, warehouse location decision. 4. Finance, dividend policy making, investment analysis, portfolio analysis. 5. Manufacturing, inventory control, projection marketing balance, production scheduling, production smoothing. 6. Marketing, advertising budget allocation, product introduction timing, selection of product mix. 7. Organizational behavior, personnel justification planning, scheduling of training programs, skills balancing, recruitment of employees. 8. Purchasing, materials transfer, optimal buying, optimal reordering. 9. Research and development, control of R&D projects, product introduction planning. A similar list can be prepared for any major field of human endeavor. Military operations research activities alone would cover an entire book. Activity 4. Identify some areas of application of OR technique in your organization. 1.6 Limitations of operations research. Operations research has certain limitations. However, these limitations are mostly related to the problems of model building and the time and money factors involved in its application rather than its practical utility. Some of them are as follows. Magnitude of computations, OR, tries to find out optimal solutions taking into account all the factors. In today's society, these factors are enormous, and expressing them in quantity and establishing relationships among these require voluminous calculations which can only be handled by machines. Non-quantifiable factors, OR, provide solution only when all elements related to a problem can be quantified. All relevant variables do not lend themselves to quantification. Factors which cannot be quantified find no place in OR. Models in OR do not take into account qualitative factors or emotional factors which may be quite important. Distance between manager and operations researcher, OR. Being a specialist's job requires a mathematician or a statistician who might not be aware of the business problems. Similarly, a manager fails to understand the complex working of OR. Thus, there is a gap between the two. Management itself may offer a lot of resistance due to conventional thinking. Money and time costs, when the basic data are subjected to frequent changes, incorporating them into the OR models is a costly affair. Moreover, a fairly good solution at present may be more desirable than a perfect OR solution available after some time. Implementation of decisions is a delicate task. It must take into account the complexities of human relations and behavior. Sometimes resistance is offered only due to psychological factors. 1.7 Models in operations research. Most of our thinking and virtually all applications of operations research in business take place in the context of models. A model is a general term denoting any idealized representation or abstraction of a real-life system or situation. The objective of the model is not to identify all aspects of the situation but to identify significant factors and their interrelationships. A model can be helpful in decision-making as it provides a simplified description of complexities and uncertainties of a problem at hand in logical structure. A major advantage of modeling is that it permits the decision maker to examine the behavior of a system without interfering with ongoing operations. Various basic types of models may be distinguished as follows. 1. Physical models. These models include all forms of diagrams, drawings, graphs and charts, most of which are designed to deal with specific types of problems. By presenting significant factors and interrelationships in pictorial form, physical models are able to indicate problems in a manner that facilitates analysis. For example, a bar chart can be used effectively as a summary presentation of a company's monthly production forecast. These models are easy to observe, build and describe, but cannot be manipulated and used for prediction. There are two types of physical models, iconic models and analog models. A. Iconic models. An icon is an image or likeness of an object or system it represents. An iconic model, the least abstract physical replica of a system, is usually based on a smaller scale than the original. The range of management problem areas where these models can be used effectively is extremely narrow. However, it consists largely of those fields that are oriented towards engineering and science. For instance, Indian Airlines as well as Air India use flight simulators to train their pilots and the members of the crew. These flight simulators are iconic models of different types of aircrafts and the trainee really feels as if he is piloting the actual aircraft. The Automobile Association of India is planning to install iconic models of several Japanese cars to train trainee drivers. Thus, an iconic model has all the operating characteristics of the real system. These models can simulate the actual performance of a product, thereby avoiding the tremendous expense of designing full-scale experimental models. B. Analog models. Analog models are closely associated with iconic models. However, they are not replicas of problem situations. Rather, they are small physical systems that have similar characteristics and work like an object or system it represents, e.g., children's toys, model railroads, etc., whereas the actual objects are complex and might not allow direct handling or manipulation. The objective of constructing models is to understand by analogy. To mathematical models. The complexity of relationship in some systems cannot be represented physically, or the physical representation may be cumbersome and take time to construct or manipulate. Therefore, a more abstract model is used with the aid of symbols. The input-output model of national economy involving several objectives, constraints, inputs and interlinkages between them is a classic example of representing a complex system with the help of a set of equations. Mathematical models are extensively used in Earth exploration. Using a set of data related to seismological characteristics of Earth, it is possible to predict the presence of oil with reasonable probability. S. An overview. All mathematical models generally comprise three types of variables: operations research dependent variables, decision variables and uncontrollable variables. The dependent variables reflect the level of effectiveness of the system. A dependent variable means that for an event described by this variable to occur, another event must occur first. The decision variables are those factors where a choice must be made. These decision variables can be manipulated and controlled by the decision maker. These are classified mathematically as independent variables or unknown variables. The uncontrollable variables are those factors which are not under control of the decision maker. These variables are also the independent variables since they affect the dependent variables. 1.8 OR. In the real world, This section gives some examples of successful real-world applications of operations research. These should give the student an appreciation for the diverse kinds of problems that OR can address. Without any doubt, the best source for case studies and details of successful applications is the journal Interfaces, which is a publication of the Institute for Operations Research and the Management Sciences, INFORMS. This journal is oriented toward the practitioner and much of the exposition is in layperson's terms. At some point, every practicing industrial engineer should refer to this journal to appreciate the contributions that OR can make. Following examples are few successful OR projects taken from recent issues of Interfaces. I. Production Planning at Harris Corporation, Semiconductor Section. 2. Gasoline Blending at Texaco. 3. FMS Scheduling at Caterpillar. 4. Fleet Assignment at Delta Airlines. V. Keep Code Service Excellence Management System. When OR is applied to real-world problems, almost all of the techniques discussed in this unit require the use of a computer. Indeed, the single biggest impetus for the increased use of OR methods has been the rapid increase in computational power. Although there are still large-scale problems whose solution requires the use of mainframe computers or powerful workstations, many big problems today are capable of being solved on desktop microcomputer systems. There are many computer packages with Lindon, Tora, Management Scientist, QM for Windows, etc. These packages include optimization mathematical programming, including linear, nonlinear, integer, dynamic and goal programming, network flows, simulation, statistical analysis, queuing, forecasting, neural networks, decision analysis, and PERT CPM. Also available today are commercial software systems that incorporate various OR techniques to address specific application areas including transportation and logistics, production planning, inventory control, scheduling, location analysis, forecasting, and supply chain management. 17. 1.9 Summary. Operations research is a distinct discipline in its own way but also become an important tool in all areas of study. It has its origin in World War II and soon became very popular throughout the world. OR is successfully used not only in military affairs but also in industry, government and business. India is one of the first few countries of the world who started using OR. OR can be regarded as use of mathematical and quantitative techniques to substantiate the decision being taken. OR takes tools from subjects like mathematics, statistics, engineering, economics, psychology, etc., and uses them to score the consequences of possible alternative actions. Today it has become a professional discipline that deals with the application of scientific methods to decision making, especially to the allocation of scarce resources. Developing appropriate mathematical models for situations, processes, systems or environment is basic essence of OR study. The model then can be tested and operated on to determine the effects of changing the values of variables with particular reference to optimization of some criterion. Linear programming, nonlinear programming, dynamic programming, game theory, marker process, waiting line theory and simulation are some of the models and techniques that are used in OR. OR also play a significant role in almost all areas of business decisions. Operations research has certain limitations also. These limitations are mostly related to the problems of model building and time and money factor involved in its applications rather than its practical utility. Magnitude of computation involved, lack of consideration for non-quantifiable factors and psychological issues involved in implementation are some of the limitations of OR. Specialists in OR are not the decision makers themselves. They only provide rational basis for decision making to executives. There is a gap between who provides a solution and who wishes to use it. Due to this gap, management sometimes offers resistance to the use of OR. The gap between OR scientists and managers is diminishing fast. OR techniques are gaining acceptance and respect day by day as they improve managers' decision-making effectiveness. Thank you for watching. We will see you in the next video with next chapter.